Welcome guys, thank you for stopping by. I'd like to show you this new model. Have not been introduced yet. Maximum power output from this model is 2 Tesla. Here I am using 66 microfarad 1.3 kilovolt capacitors in a capacitor bank, and with this setup I'm able to get 2 Tesla. Let me show you the power output from this model. Here we go. This is the pulsation speed at 2 Tesla. As I decrease down to 1 Tesla, this is the pulsation speed at 1 Tesla. So at 1 Tesla it pulsates 1.9 Hertz and will give you 112 pulses a minute, roughly around 800 pulses per session. At high output, you can, by the way, adjust it from low to high with this variable resistor. Here it pulsates 0.5 Hertz, so every 2 seconds you will get a pulse. You'll get about 30 pulses per minute, totaling of 240 pulses per session. This kit is fairly easy to install into the case. For the case you can use GameMax Spark Mini. Here is some accessory. This is our 3D printed support for the motherboard to go into the case. I will show in more details. You can see the link down below this video where I can show you how this is being mounted. By the way, if you're curious to see how do I mount it into the case, stay tuned, subscribe, and in the next video or two I'll be showing how to place this into the case. So as I said, I have 3 models that I'm offering right now. One is 1.2 Tesla, this is 2.0 Tesla, and the third one is 2.4 Tesla. Each model you can adjust intensity down to 50% of its rated power. So this and later I'd like to introduce 2 more models. 1.7 Tesla, which will be smaller than this and lighter, and you can install it in a more compact case. And another one will be introduced is 1.6 Tesla. Stay tuned for those. These are some of the accessory which will come with the kit. This you can purchase separately, or I have free files. You can 3D print all this, and again I'll link down below this video where you can download them, and if you have a 3D printer you can print those out. Same goes for these. All these can be 3D printed, and I will leave the link down below the video. You can download for free all this and 3D print it yourself. Okay, let me discharge capacitor bank, and I'll show you how it looks below this pulsar down underneath. So here is the bottom side of the kit. If you planning to mount it into the case with these supports, you won't need this or that, but I do have them available, and they will come with the kit just in case you want to use a different case for this setup and try to mount it. This would be a support, so if you look from this way, it's gonna be all same flat. This is support for thyristor. This would come fully isolated. That's where the high voltage is, and so as all the exposed soldering joints, everything is going to be insulated. So also this you can use this as supports for the board. Here there is 6 of them, 1 2 3 4 5 6, and then you can mount them onto your case and mount your PCB to the supports. My guess, you're probably wondering, why am I using this motherboard for different models? Basically, this setup is fairly reliable. I haven't really had any failures for this, and that's why I am using different capacitor bank, starting from like 84 microfarad and all the way to 600 microfarad. And depending on the capacitor bank, I am able to get different output from this setup. So I am using polypropylene capacitors and analog charging circuit here with the isolation from the transformers. They will step up to 250 volt AC, and then I will actually 500 volt AC, and then I will double it with the voltage multiplier. There's 2 diodes underneath this fan, and in conjunction with the capacitor, this works as a doubler, and I'm able to recharge this capacitor bank to 1250 volt, and then through the thyristor discharge it into the coil. This is my classic 3.5 inch coil, which I've been using for a while now, and there has been a lot of improvements done to this coil, and I'm happy with the results I am getting from it. Kit comes with this coil as is, completely built, so your job would be to make a few holes in the case and insert your potentiometer, a couple LEDs, a voltmeter for the capacitor bank, power input, and power on off. So shouldn't be that hard. Everything is configured and set to work at as it's designed, so will simplify your job greatly. Alright guys, if you have any questions, leave them down below this video. Give me a thumbs up please if you like this video, and I'll see you in the next one.